हेलो फ्रेंड्स, वेलकम टू माय चैनल। मैं हूं आपका दोस्त महेश कुमार। और आइए स्टार्ट करते हैं क्वेश्चन रिलेटेड टू हाइड्रोस्टैटिक फोर्सेस ऑन सरफेसेस। फ्रेंड्स, क्वेश्चन स्टार्ट करने से पहले मैं आप लोगों से रिक्वेस्ट करना चाहूँगा कि प्लीज़ मेरे वीडियो को लाइक कीजिए, कमेंट कीजिए। सो फ्रेंड्स, आइए स्टार्ट करते हैं क्वेश्चन। A vertical sluice gate is used to cover an opening in a dam. The opening is 2 meter wide and 1.2 meter high. Okay friends, so dam जो है, गेट जो है, ओपनिंग गेट 1.2 मीटर हाइट है and 2 meter wide है. Okay. On the upstream of the gate, the liquid of specific gravity 1.45 lies up to height of 1.5 meter above the top of the gate. Whereas on the downstream side, the water is available up to a height touching the top of gate. Find the resultant force acting on the gate and position of center of pressure center of pressure. Find also the force acting horizontally at the top of the gate which is capable of opening it. Assume that the gate is hinged at bottom. Friends, this is the condition it has given. This is the condition it has given. Here, this is the gate, opening gate, and this side is the upstream side. जिस डायरेक्शन से सपोज कीजिए फ्रेंड्स, this is the gate, this direction water can move. So फ्रेंड्स क्या होगा, दिस इज अप स्ट्रीम होगा और इधर से अगर बाहर जाएगा तो क्या हो जाएगा, ये डाउन स्ट्रीम हो जाएगा, डाउन स्ट्रीम। दिस इज अप स्ट्रीम क्योंकि जो लिक्विड है इस डायरेक्शन से इंटर करेगा एंड इस डायरेक्शन से आउट होगा। दिस इज अप स्ट्रीम, this is upstream and this is downstream. Now here, since gate is closed, then what happened, liquid will store in this part, and when it will be open, then liquid will flow from this side to this side. So this is the upstream, this is the downstream. Okay friends, now here it is saying that the height of the gate is equal to 1.2 meter. The gate is like this, the gate is like this is the height of 1.2 meter and it is like this something. The width is equal to 2 meter. Okay friends, now here it is saying that this specific gravity of 1.45 density liquid, or you can say density equal to 1450 kg per meter cube, is in upstream side and up to height 1.5 meter above the gate. Okay friends, and in downstream side it is saying that water is available and it is up to top of the gate. Water density is equal to 1000 kg per meter cube. Okay friends, gate is hinged at bottom, so this is the bottom point and gate is hinged at this point. Now clear, this is the center point of the gate. Okay friends, this is the G is the center point of the gate. Now this, because of this liquid, one force will work at the gate and this force is F1, and because of the downstream liquid also one force will work on the gate and it is equal to F2. Okay friends, now you see here, friends, F1 is the force by the liquid of a specific gravity on the gate. So F1 is the force which is working by specific gravity 1.45 and F2 is the force which is working by this water. Okay friends, now see here, we know friends, the force exerted by the liquid, क्या होता है, rho 1 g a h bar, rho, you can say rho g a h bar. Since here density is different, so we'll put here rho 1 g a H1 bar, because friends here you see the H bar is different. In this case the H bar equal to different, and in this case H bar will be different, because the H bar is the distance. Suppose friends, this is the liquid. So what is H bar? From G point to the free surface. This is the free surface of liquid. This is the free surface of liquid. So friends क्या होगा? This is the G point, and center of gravity of the body to free surface is known as H bar. But in this case friends, suppose this is the gate, and this is the free surface in one direction, and this is the free surface in the other direction. So friends, this is the G point, or we can say center point. So from here we can say this is the H1 bar for this liquid. Suppose this is 1.45 liquid and this is the water. So H1 bar for this liquid is this much, and for water we can say this free surface to center of gravity, it is something H2 bar. So H1 and H2 bar will be different for both the case. Okay friends, similarly here density is equal to how much? Density in this case 1450, and here density is equal to 1000 kg per meter cube. Here kg per meter cube. Okay friends, now see here, for first case if you calculate in this direction, in this part, so क्या होगा friends, जो फोर्स एक्सर्टेड F1 होगा वो होगा ρ1, फोर्स एक्सर्टेड कितना हो जाएगा फ्रेंड्स, यहाँ पर ρ1 G A H1 bar. A is same because here 1.2 into 2 is the area. तो बोथ केस में क्या होगा फ्रेंड्स, एरिया सेम होगा. सो दिस इज A. ρ1 क्या हो जाएगा फ्रेंड्स, ρ1 इज द 1450 into 9.81 G value into area is equal to how much, 1.2 into 2 into height H1. H1 in this case friend what? H1 is what? H1 equal to, see here, this is the center point. Total height is 1.2. So half distance is equal to how much? 0.6 plus 1.5. So friends यहाँ से क्या हो जाएगा? See here, H1 bar is equal to 1.5 this distance plus 1.2 divided by 2. Okay friends, this is the 1.2 divided by 2 equal to total, it will come H1 bar equal to 2.1 meter. Okay friends, now from here if you calculate, so force exerted in upstream side 71691.48 Newton it will come. Okay friends, similarly here, you see in the downstream direction how much force will work. Force F2 is equal to what? ρ2 G A H2 bar. So in this case friends, H2 bar is equal to what? Liquid is there up to gate. So from gate height is equal to 1.2 divided by 2. So this is the, we can say from here friends, कितना हो जाएगा? 1.2 divided by 2 is the H2 bar. So friends here you see F2 is equal to what? ρ2 G A H2 bar, and from here ρ2 is equal to 1000 kg per meter cube, and H2 is equal to 1.2 divided by 2 is equal to 0.6 meter. Now if you calculate F2 equal to 1000 into 9.81 into 1.2 into 2, this is the area and this is the H2 bar. So from here F2 is equal to 14126.4 Newton it will come. So friends, we calculated here F1 also calculated and F2 also calculated. But friends, if you see here, F1 is working in this direction and F2 is working in opposite direction. So net force is equal to what? We can say resultant force of the gate is equal to what? F net is equal to, here F resultant is equal to F1 minus F2. So friends, it will come 71,691.48 minus 14,126.4. So the value will come 57,565.08 Newton. So it will work in this direction. So resultant force in it is work in this direction. Okay, friends. Now friends, we have to find the center of pressure. Now we have to find the center of pressure. See friends, here you see this is the F net. This is the F net value, and it is working in this direction. I just shown here. This is the F1 value. This is the F1 value which is working at the H1 star, because this H1 star is the center of pressure where the force will work, and from here this F2 is working on the H2 star center of pressure in this direction, and the F net will work on the some other point. So this is the H star. This is the center of pressure of resultant force. Okay, friends. Now we have to calculate. We have to calculate the center of pressure of resultant force. Center of pressure of resultant force. So friends, how can we calculate? First, we have to calculate what is the H1 star. What is the H1 star? Or center of pressure of the force working in the upstream direction, and upstream side, and F2 here H2 star center of pressure in downstream side. So first we have to calculate friends H1 star. H1 star is equal to H1 bar plus Ig upon AH bar, since the plate is in vertical. Okay friends, since the plate is vertical, so we will use this formula. H1 star is equal to H1 bar plus Ig. Ig is the moment of inertia about center of gravity, and a H1 bar. So friends, here we know that in this direction the H1 bar is equal to 2.1 meter. So this is the 2.1 meter. Ig is equal to what? Moment of inertia about the center of gravity is equal to what? BDQ by 12 for rectangular shape. So BDQ by 12. So B is equal to width is equal to 2 meter and height is equal to 1.2 meter. So it will come 2 into 1.2 into to the power 3 divided by 12 meter to the power 4. So Ig value will come, moment of inertia, it will come 0.2288 meter to the power 4. Okay friends, so from here this H1 bar calculated, Ig value calculated, area we know that 2 into 1.2 meter square is the area. 1.2 meter square is the area. So from here friends, we are able to calculate H1. Similarly we will calculate H2. So friends, from here you see H1 is equal to 2.1 plus 0.288 divided by area 2 into 1.2 into 2.1 is the H1 bar. So if you calculate all these things, the H1 star value will come 2.1571 meter. So from here you see friends, the H1 star value will come 2.1571 meter. Okay friends, so H1 star we calculated. Similarly for S2, or we can say water side, S2 bar plus Ig upon A S2 bar. Ig is same, moment of inertia for opening gate is same for both the case. So in this case friends, S2 star is equal to, and S2 bar is equal to what? This 1.2 divided by 2 is equal to 0.6. So here it will come 0.6 is the S2 bar. So from here friends, we are able to calculate S2 star equal to 0.6 plus 0.288 divided by 1.2, 2 into 1.2 into 0.6. So if you calculate here, the S2 star will come 0.8 meter. 0.8 meter. So friends, from here we can say H2 star value will come 0.8 and H1 star is equal to this much and H2 star is equal to this much. Now we have to find the value of now friends we have to find here. See, this H2 star value as calculated. H2 star value is equal to how much? H2 star value is equal to 0.8 meter and H1 star is equal to how much? 2.1571 meter. Now we have to find what is the H star, center of pressure for the. Now we have to find the F net and center of pressure for the resultant force. So let it is the H star. Friends, you see here, this is the hinge point. Gate is the hinged at the bottom. Gate is hinged at the bottom. So we will take the moment at the bottom. This force is working. F1 force is working at P1 point and F2 force is working at point P2. F2 force is working at point P2. So we have to calculate first, friends, from hinge to P1 value and from hinge O to P2 value. Then we are able to calculate. Let here this point is the P for resultant force. Okay friends, so this is the point P for resultant force. Now here first we have to calculate, friends, first we have to calculate the OP1 distance. OP1 distance, because since it is hinged at point O, so we have to calculate OP1. OP1 is equal to what, friends? OP1 is equal to total height 1.5 meter plus 1.2 meter minus this H1 star. Then it will come this OP1 value. OP1 value. Similarly here for OP2 total distance minus this H2 star value, then it will come OP2. So friends, you see here distance OP1 is equal to total distance 1.5 plus 1.2 minus H1 star. It will come, friends, 2.7 minus 2.1571. It will come 0.5429 meter. Now friends, here OP2 distance is equal to 1.2 minus 0.8. 0.8 is the H2 star value, so it will come 0.4 meter. Now friends, we are able to we calculated here this distance OP2 and OP1. Now we have to find the value of this OP, where the resultant force is working. So for F net, we are the distance from hinge OP. So OP is equal to what? We will take the moment, friends, this F1 into this distance OP1 minus this OP2 into F2. So friends, from here we directly calculate here OP distance is equal to what? F1 into OP1 minus F2 into OP2 divided by the value of F net. So we know that the value of F net is equal to, we can say resultant net force is equal to 57565, and this value already calculated 71691 is the F1 value into this is the OP1 distance 0.5429 minus this is the F2 value, force F2 14126 into 0.4 is the OP2 value. So after calculating, friends, we will get the OP value is equal to 0.5779 above the hinged, or we can say H star value is equal to for F net we have to minus from this is the P value. So OP we have to minus from total height. So total height we have to minus means 1.5 plus 1.2 minus 0.5779 equal to 2.1221 meter from the free surface. This is the H star value. Okay friends, this is the H star is, or we can say center of pressure of the resultant force. Okay friends, now here you see last point is that force at the top of the gate which is capable of opening the gate. Force at the top of the gate, कितना इस पे force चाहिए to open the gate in this situation. So friends, we will calculate by taking the moment. Here let's suppose the force F3 is working on the top of the gate in the downstream side. Okay friends, let F3 is the opening force और इतना लगाने के बाद जो है एक गेट ओपन हो जाएगा. This side working friends, this is the F1 force which is working at the point P1. So OP1 distance we know that 0.5429 meter, and F2 force is working in downstream side. So and working at a distance 0.02 P2, 02 P2. So and its distance is equal to 0.4 meter. Now friends, you see here it is working, this F3 is working at the top point. So from top to hinged distance is equal to the height of the opening, so 1.2 meter. So all value we are getting. So we'll take the moment at hinged O. So F3 into 1.2 is the anti-clockwise, minus if you see here F1, this is, it will go clockwise, so minus it will come minus F1 into 0.5429 plus same again anti-clockwise, it will come F2 plus 0.4 equal to 0. So friends, from here F3 value will come, and it will come if you calculate. So F3 value is equal to how much? 27725.53 Newton it will come. Okay friends, so we calculated here net force F1 minus F2, this is the net force, and we calculated here friends F1 value calculated, F2 value calculated, and we separate, then net force it will come which is working in this direction. Then we have to calculate this H star value, so we calculated here H star, and the last point is that force is required to opening the gate from the downstream side. So this also calculated here, F3 equal to 277.25.53 Newton. Okay friends, so friends नेक्स्ट क्लास अच्छा लगे प्लीज लाइक कीजिए, कमेंट कीजिए, सब्सक्राइब कीजिए फ्रेंड्स, दोस्तों के साथ शेयर कीजिए फ्रेंड्स. थैंक यू.